Ladies and gentlemen, good morning. How are we today? Good. Great, right? Good. Sometimes you can say, couldn't be better. 比这个再好也不过啦，是不是？哦 ，couldn't be better. 如果说おはようございます呢？你要回答おはようございます，对不对？哦，如果说お元気ですか？元気是什么意思？元气，对不对？哦，就是问你精神好不好啊？哦，你要说什么？おかげさまで，哦，托你的福，我很元気です。哦 ，OK， right， OK， As usual, let's recap what we have learned in the last lecture. Last lecture, we learned crystal system and the Bravais lattice. I hope you still remember. The crystal system involve Bravais equal to, or you should say, involve Bravais lattice plus what? Plus basis, right? Plus basis. Okay, this is important. I want you to remember, okay, because in the following lectures, we will also talk about crystal system. And you know that crystal structure of the metal, we start to learn SC stands for simple cubic, right, structure. FCC, face center cubic structure. BCC, body center cubic structure. And HCP stand for hexagonal closed pack structure, right? Okay, so you need to know that. So what is this? This is BCC, right? BCC. Okay. And then we also learn unit cell. In a unit cell, this is a unit cell. Unit cell is the smallest repeated unit. Okay, so you can repeat. And this is smallest repeated unit. And if you pack this together in 3 dimensions, you can make a crystal, right? Okay, so in a unit cell, we need to know coordination number. What is coordination number? Coordination number is the one, the sphere or the atom attached or the nearby atoms, the number of the nearby atoms. Okay, for example, this one, there are how many atoms nearby this atom in the center? 8, right? So coordination number is 8. And you also need to know the atoms per unit cell. How many atoms in this unit cell? 2, right? You have 1 in the center. You have 1/8 in 8 corners. Right? So 1/8 in 8 corners, that means 1/8 times 8 equal to 1. So you have 2 atoms, right? And you also need to know A and relationship between radius and edge length. Edge length here, right? I hope you still remember. And after that, you need to know atomic packing factor. This is atomic packing factor, right? So the definition of the atomic packing factor is the value of the sphere divided by value of the cube. Right, value of the sphere divided by value of cube. That means what? How many values was occupied by atoms in a unit cell? Right? Okay, and then after that we learn theoretical density. This is the density, right? The definition of density is the weight divided by volume. And if we can measure the density, or also we can calculate the density by this equation. I hope you still remember. I want you to remember this equation. Okay, this will be in your final exam. Right. So N is what? N is the number of the atoms in the unit cell, right? A is the atomic weight divided by value of the cube and times what? Avogadro number. Right? Okay? And after that we learn polymorphism and allotropy. So this is the theme, right? Because the temperature change, the structure change. the structure of the atom rearranged. So the value expand. Remember, I show you a video. Okay, so this is what you know. What is the polymorphism, or this allotropy is the same as polymorphism. Right, okay. And then this is also one of important information you need to know in this section. Is the crystal structure equal to what? Crystal lattice. Well, that's also called Barbier lattice plus basis. Right? So for the crystal lattice, there are only 14 crystal lattice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? And then, so you have 7 crystal classes. Right? Crystal class. And you have 4 types of lattice type. Lattice type means the atoms in the inside this crystal classes. So you have 14 here. So for the basis, so this is the crystal lattice, which is 14 types. And the basis is you can have atom, like in this corner, you can have atom. You can have molecular, right? Carbon dioxide. You can have a pair, sodium chloride, right? You can have atom pair, like carbon-carbon. Remember? Okay, so this is important. I also want you to remember. So, so for example, crystal structure equal to crystal lattice plus basis. Okay, so I don't show you in 3-dimensional crystal lattice, but this is 2-dimensional repeated unit. It's the same. So if you have this is atom, this is the 2-dimensional. This can be this is what? This is called lattice. And this is called base. So this is repeated unit, right? Repeated unit. 2-dimensional repeated unit. You can repeat this to this, to this, to this. How about this one? Can this be regarded as a repeated unit? Yes, right? Because this can repeat to this direction, to this direction, to this direction, to this direction. But the same basis, okay? But different start point. Okay, this is the same lattice, right? Same lattice. Okay, so this and this can these two can be regarded as a repeated point, a repeated unit too. Okay. Early bird, remember? Okay, just give you a hint. Okay, so today we are going to start with another topic, and also it's also important, and we are going to start. We are going to know that how to address, because we already learned crystal structure, and today we are going to learn how do you address a point or points or directions or planes in the unit cell. Okay, how do you when you want to talk about the planes, you need to have the same language with other scientists, with other engineers. So we need to define this. So to make sure we are talking about the same thing. Okay. So now we go to move to the topic of the crystallographic points, directions, and plan. As I just told you, this is a unit cell, and if you have a point here, how are you going to address this point, and to let other people, let other scientists or engineer knows you are talking about this point. Okay, not this one. And also direction. You have a direction like this. How are you going to make sure you are talking about the same thing with others? Okay, how about a plan? Plan is this one, this plan, or this plan, something like this. So we have a systematic information. We have a systematic things today you know. So you will understand, and you need to know how to address points, directions, and plans. Right. So the basis for determining index values is in the unit cell with the right-hand side coordinate systems consists of the 3 XYZ axes situated at one of the corners, and the coinciding with the unit cell edges. So this is from the right hand side, from here, x, y, z. That's what our definition. X is here, y is here, and z is here. And this is origin in here. Okay, so we have 3 axes. Okay, so first of all, let's talk about the point coordinates. The point coordinates P here, for example, you have a point here. So how do you address this? Of course, I'm sure you learned this before. For example, length of the x-axis is a, and then if this length is a, and then this is the q is the fraction length of the a along the x-axis, so you will use qa here, right? And y is the length of the y is b, and but this is the r here is the fraction, so you here the fraction here you use rb, right? And then x, the y-axis, the length of y-axis, z-axis is c, so you use the fraction of the fraction length of the c is s, so you use sc here, right? So within these 3 information, you can address this point QRS here, because you remove ABC is because you already know A equal to B equal to C, or A is 1, B is 2, C is 3, for example. It's like this. So when you just want to address this point, you just use QRS here. So other people will understand when you talk about Q is x-axis, R is y, S is z, the length of the, okay, the fraction. Okay, easy, right? How about direction? There are two topics we want to know. One is cubic structure, cubic crystal, and one is hexagonal crystal. This is very simple, so I just let you know. So this is a cubic structure, which is A equal to B equal to C, right? A equal to B equal to C. So there will be A. That's the most easy case you want to know. So the crystallographic direction is defined a line between 2 points or a vector. I think you have learned this before. So if you have a vector, for example, from here to here, how are you going to address this? So there are 4 steps to determine 3 directions. So I want you to know this, and this is important. So step 1 is the vector passes through the origin. The vector, you know, just now I show you a vector, right? It needs to pass the origin, okay, of the coordinate systems. Any vectors may be translated throughout the crystal lattice without alternation if parallelism is maintained. So this vector can be parallelly removed, but this vector need to pass the origin. Okay, so, and the second step is that the length of the vector projection on each of the 3 axes is determined. These are measured in terms of the unit cell dimensions A, B, C. So this vector has to do the projection to the A-axis, to the x-axis, y-axis, and z-axis. And you got the length in the A-axis, in the y-axis, and z-axis. Okay? So you got 3 numbers. So these 3 numbers are multiplied or divided by a common factors to reduce them to the smallest integer value. These 3 numbers need to be the smallest integer value. Okay? And the step 4 is that the 3 indexes is not separated by commas, are enclosed in a square blanket. Square blanket is this is called square blanket. Okay? And we use UVW to address these 3 points, 3 numbers. Okay? The UVW need to be integer, corresponds to the reduced projection along the X, Y, Z axis respectively. You might don't know what I'm talking about, right? So let's practice now. Let's practice according to that 4 steps to give a number, and then everybody know what are you talking. So for example, this is a vector here. You know, you have x-axis, y-axis, and z-axis, right? So this vector is here, and this is about. Okay, so let's go to the step 1. Step 1 is what? Step 1 is this vector need to pass the origin. Origin is here. So yes, this vector is, you need to pass the origin. Okay, how about if the vector is here? You need to remove this vector down to this part, parallelly. Okay, so this is pass origin. Okay, first one. How about the second one? Second step, you just need to remember the key word. Step 1 is called origin. Step 2 is called projection. Okay, the step 2 projection is what? This point needs to project to the x-axis, y-axis, and z-axis. So let's project this vector to the x-axis. It's here, which is about what? Half of A. Okay, half of A. And how about B? You do the projection to y-axis. That will be what? The B, right? B. Because we understand this is called A, this is called B, and if you project to here, this is called C. So how about this? Project to C. Project to z-axis. 0, right? 0. So that will be half of A, B, and 0, C. This can be called 1B, right? 1B. Okay, so this is the projection. And what's the step 3? Step 3 is that you need to make it become the smallest integer by multiplying or subtracting, right? So you need to become, you take this out, A, B, C out, right? So this half of A and 1 and 0, half and 1 and 0. And then later on you should make it become smallest integer. So you type multiplication by 2. So this will be half times 2 become 1. This become 2. This become what? 0. So you will get this. So this step 3, right? Step 4 is what? Square bracket here. So step 1, step 2, step 3, and square bracket. So this is 1, 2, 0 square bracket. So when you have this number and square bracket, and then you understand we are talking about this vector. Vice versa. If I give you this vector, you will know this is the index, this is the number you are talking. Right? Okay? So, 4 informations, 4 steps. First, origin. Second, projection. Third, reduction. Reduction make it become the smallest integer. Right? Step 4, enclosure. Okay, ladies and gentlemen, this is very important. You need to learn. You need to learn this. When I see your final exam paper and you cannot answer this, and you want me to pass you, no way. Okay, there's no way I will pass you, because if you don't know this, it doesn't mean you learn material science well. Okay, so this is important. So another one is vector. So you understand we have a square bracket, right? UVW square bracket. So if I give you 1, 0, 0, can you draw this to me in this unit cell? Can you? Please do it. Right? You have 4 steps, right? Step 1, step 3, step 4, step 5. But if I give this number, you know you have to do step 4 first, step 3, step 2, and step 1. Whatever. So how do you say 1, 1, 1, 0, 0? That means this projection to x-axis is 1, right? And projection to y is what? 0. Projection length to the z-axis is 0. So this is, how do you draw this vector for me? Can you? This is 1, right? This is 1. Easy. How about 1, 1, 0? The 1, 1, 0 is projection to 1, right? X-axis, Y-axis, Z-axis. So X is 1 here, and Y is 1 here, and Z is 0. So this and this become this one, right? This is 1, 1, 0. Square bracket, 1, 1, 0, square bracket. How about 1, 1, 1? 1, 1 is projection to the 1 here, projection to 1 here, and projection to the 1 here. So if you have these three vectors get together, the vector will become this one, right? Okay. Okay, how about this one? Square bracket 1, 1 over bar and 0. What does that mean, 1 over bar? 1 over bar is a negative sign. So you need to go to negative direction. This is positive, right? And this is negative. So for example, this 1 is positive direction. This 1 is negative direction. So this one need to go to this place. Okay, so this 1 square bracket 1, 1 over bar, and 0 square bracket. Okay, so it's the minus direction of the Y. Okay, so this is the 1 square bracket 1, 1 over bar, and 0 square bracket. So this is 1 here, right? And 1 here, 1 here. So origin, you need to pass to origin, of course. And then 1 here, right? And projection to 1 minus 1, 0. So it's 1 here, right? And another 1 here, because it's from the positive, this is negative. And 0 is here. So these two vectors, you have the sum of these two vectors, that will become this one. So get the point P here. So this P point is square bracket 1, 1 over bar, 0 square bracket. Easy, right? Piece of cake. Okay, so let me just remind you, it's very important. Let's 4 steps: origin, projection, small integer, right? Value by multiply or divide it. Okay, and square bracket. Square bracket, no commas. There's no comma here, right? Okay, UVW. Right, okay, how about this one? Can you do this for me? If I give you a vector here, what's this? Again, origin, yes, origin. Projection, here, here, and y-axis. Right, so this 1 here, let's say half of the z-axis, right? Let's say, okay, and this is y is 0. So it's 1, 0, and half, right? 0.5. So this is projection. Step 3, smallest integer. How do you make this smaller integer? Times by 2 for all these 3 numbers. Right? So 2, 0, 1. And then step 4, square bracket. Again, so if I tell you square bracket 2, 0, 1 square bracket, you need to know this is the vector. However, if I give you this vector, you know this is, you need to use square bracket 2, 0, 1 square bracket to address this vector. Okay? Easy. How about this one? How about this yellow? Sorry. I'm sorry. Why I say yellow? Why this is a red vector. A color marked in red color, right? How about this one? So again, does it pass origin? Yes. Second, projection to this one, which is what? Positive or negative? First for x-axis. Negative, right? Negative, because it goes to another way. Okay, x, y, positive or negative? positive, right? Z positive or negative? Positive. So that will be minus 1, 1, and 1. Okay, so does it need to be the small? Is this the smallest integer value? Yes. So you don't need to do anything, just square bracket. But remember, this is over bar here. Okay. Right. So what does the mean family? When we talk about this one, will it be the same as when we talk about this vector? Will it be the same as this vector here? Will it be? I'm going to tell you this very soon. Okay. But before we talk about this, I hope you remember we talked about another one called hexagonal crystal, because BCC, FCC, and HCP, right? And FCC actually is the same as HCP, but different packing sequence. One is AB, AB, one is ABC, ABC, right? ABC, ABC is for FCC, AB, AB is for HCP. So when you talk about this hexagonal crystal structure, they have 4 axes, like XA, A1, A2, and A3. Remember A1, A2, and A3, and Z axis. Right. So again, A1, A2, A3 we call basal plane. Basal plane. Okay. They are 112 degrees separate from each other, one another, right? So total is about what? 360 anyway. So Z axis is perpendicular to the basal plane. Perpendicular to the basal plane. Okay, so the 4 axes are also called Miller Bravius. Okay, you don't need to remember this, but what you need to know is, you have 4 numbers, U, V, T, W, to address information in the A1, A2, A3, and Z for this U, V, T, W. Okay, again, you need to follow the 4 steps to give the numbers for this direction. Okay, A1, A2, A3, and Z. 4 steps. Okay, how about this one? If I give you the vector in this direction, how can you do this for me? Of course, you already know this is 1, 1, 2 over bar and 0. Square bracket. But how can you get this number? Let's put this in a 2-dimensional first for the A1, A2, and 3, because you know Z is 0 anyway. Okay, so you have a vector here, and then you have A1, A2, A3, because you know that this 3 is 120 degree, 120 degree, and 120 degree. So this vector here, you project, you do the, of course it passes the origin, right? And you need to do the projection, which is about half of A1. This is the half of A2. And this is what? This is minus, right? This is positive and this is negative. So you will get what? You will get half of A, half of A1, half of A2, and minus 1A, 3, and 0, Z. So you get this projection, and then you go to step 4, smallest integer. Smallest integer, very easy, because you times all these 4 numbers by 2, right? By 2. So you will get 1, 1, minus 2, and 0. And you need to use square bracket to between this for this number. So that's 1, 1, 2 over bar and 0. Easy, right? Easy. Right. So I give you another job. 0, 0, 0, 1. What's the vector for this 0, 0, 0, 1? Easy, right? Because 1, 0, 0, 0, that means the projection for the A1, A2, A3 are all 0, so it will be here. And 1 is what? 1 is this Z direction, so this is All we know is 0, 0, 0, 1. Right? And how about this one? 1 over bar 0, 0 square bracket. Again, A1 is 1, right? So it's here. A2 is what? A2 is here, but it's negative sign here. So you need to, this is positive, this is negative. So point here, and for a z-axis, A3 axis and z-axis, they are all 0. So there's no projection here. So you have these two vectors, and the sum of these two vectors will be in this direction, right? So this is the one. This direction, and here we will get to this one. So this is square bracket 1 over bar 0, 0 square bracket. Are you with me so far? Yes, right? Easy, right? 簡単ですね。Good. Right, okay. So how about this one? 1, 1, 2 over bar 0. So you know you have 2. So you need to become what? Because this is 1, right? So you know that this is half. Right? This is half. This is 2, 2. You can regard like this. So 1 here and 1 here. This is the 1. Because this 2 is about half. And then, of course, this go to this direction. It's 1, 1, 2 over bar 0. Okay, so important things. When I told you that FCC and HCB, actually they are the same family but different packing sequences. So actually you can convert these 3 axes to become 4 axes. So to convert from a 3 index system to the 4 index system is U prime, V prime, W prime. You can turn it to the U, V, T, W. For example, if I tell you this vector here, you also can have this vector into this system by this equation. Okay, you have 3 numbers here. You can make it to become 4 numbers. And actually, this is not so important. In the future, if you need this, you just check in the Google, or you just find my lecture note. You can get this number. So you don't need to remember all this equation. How do you do this calculation? I just want to tell you, you can convert the 3 axis vector to become 4 axis vector. Okay, so don't worry about it. Here, just give you an example. You have a square bracket 0, 1, 0. How can you transfer this number to become 4 numbers in the hexagonal closed pack Unix cell? So this is the equation, and this is 1, 0, 0, 1, 0. So you just put the number here, right? So the U is 0 here, and then V1 is V prime is 1. So you put 1 here. Okay, N is a common number. You don't need to worry about this. Anyway, so please do this, and then you will find the answers. Okay. Right. So now another information or another things I want you to remember is very well is that the family of the direction. For example, this is FCC. When we talk about the vector here, for example, this is a vector, right? This is also a vector. Are they talking about the same thing? Yes, they do. How about this one? If I talk about this vector and I talk about this vector, are they the same? Of course, it gives you the different numbers, but in this case, in this cubic structure, BCC, it's the same thing, right? It's just different angle only. So that's what we talk about. We use family to address these different directions. So That's in the cubic crystal. This is a cubic crystal. Cubic crystal means A equal to A, length of A equal to length of the length in the x-axis equal to the length in the y-axis equal to the length in the z-axis. That means A here. So the cubic crystal structure directions in all ages like this: 1 0 0 1 over bar 0 0 0 1 0 0 1 over bar 0 0 0 1 0 0 1 over bar. Index equally equivalent directions are grouped together into the family shows this one. So we call this Kara blankets. This is square blanket, right? This is square blanket. This is called Kara blanket. So when I talk about 1 0 0, it means what? When I talk about Kara blanket, 1 0 0 Kara blankets, it means that we are talking about all these directions. So this is what we call the family. You might say, why, Professor? Does this equal to this? Yes, it does. Why? This one, for example, 1 0 0, right? 1 0 0 here. Okay, and 0 1 0 0 1 0 is here. So when you talk about 1 0 0 and then 0 1 0 is the same, right? When you think of this, so this is the family. Okay, so this is what we call a family of directions. So 1 0 0 0 1 0 and 0 0 1. So you say, well, Professor, can I use 0 0 Kara blanket 0 0 1 Kara blanket? Yes, that's okay. So if you use Kara blanket, it means it's a family. Okay, it's a group of the directions, which is talking about the same thing. How about this? In a tetragonal systematic, how about this? This 1 0 0 0 1 0 and 0 0 1, they belong to the same family, which is Kara blanket 1 0 0 Kara blanket. How about this one? Are they talking about the same family? 1 0 0 0 1 0 and 0 0 1, are they the same? No, they are not. Why? Because this is tetragonal symmetric. This is A length in the x-axis equal to length in the y-axis, but it doesn't equal to the length in the z-axis. So when we talk about this one, yes, they are a family, but this one doesn't belong to this family. Okay? So in the tetragonal system, one square blanket 1 0 0 and the square blanket 0 1 0 are equivalent, but square blanket 1 0 0 square blanket and square blanket 0 0 1 square blanket are not. Why? Of course, when you see this, the length is different. In the future, we are talking about the density, the planar density and the linear density, and this is linear density is different from this one too. Okay. So now let me give you an example. For a cubic crystal, Kara blanket 0 0 1, how many directions belong to 0 0 1 or 1 0 0? This is 0 0 1, right? How many? There are 6, right? 1 2 1 2 3, right? Or they are all positive. How about negative? 4 5 6, right? So there are 6 members in the family in the square blanket, Kara blanket 0 0 1 Kara blanket. 6 members. No problem, right? How about this one? How about this one? How many members in the family? Kara blanket 0 1 1 square blanket. Sorry, Kara blanket. How many? So this is called all the face diagonals. How about this 0 1 0 1 1? What is 0 1 1? So 0 1 1, it can be 0, right? And 1 1. So we are talking about this one. or you can get 1 0 0. 1 0 0 is 1 1 1 0 1 1 0 1 1 0. So it's this one. So when we talk about x, y, we are talking about this one. So how many members in the family? 12. Because when we think of the xy plane, how many? 1, 2, 3, 4. Yeah, 4 in the xy plane. Again, they will also have 4 in the yz plane. They will also have 4 members in the xz plane. So there are 12 members in the family. Okay? Use a little bit imagination to understand this. How about Kara blanket 111? How many members? 111 means what? Means this one, this direction. This direction. Right? This direction. There are 8 members. Why? You can think of one. If you talk about the xy plane, above xy plane there are 4 members, right? 1 back here. 1, 2, 3, 4. And below xy plane there are another 4. So you have 8 members in the family. Okay? Hope you understand this. Okay? If you don't, you are welcome to come to me. Right. So this is one of the most important information you need to digest. You need to know. And another important information is how to address a plan or plans. And that's what we call Miller index. Miller index. Right. So before we go to this topic, let's refresh ourselves. It's the Kahoot time. Right? It's the Kahoot time. Right. I show you this, right? Early bird. Remember? 所以早点来还是有好处的，是不是？ Right. So next topic is, right, I think we can finish this. Next topic is how to address the crystallographic plans. Of course, there are a few topics here we need to understand. So the important one is the crystallographic plan is that, again, you need to, when we talk about this, not only to address the vector, but also you need to address the plans, right? Okay, but when we talk about a plan, for example, this one, to make sure you and your friend talk about the same plan, you need to have a set of numbers. Okay, you need to have a set of numbers. So unit cell is the basis, of course. Everything starts from the unit cell. The crystallographic plan are specified by 3 Miller indexes as HKL. This one we call parenthesis HKL parenthesis. Okay. Right. So you use HKL. So if you have a square blanket, we know you are talking about a direction. But if we use parentheses, we know you are talking about a plan. Okay, and this one especially is called Miller indexes. What's Miller index or Miller indexes? It's a set of 3 integer number. Again, a set of the 3 integer number. Okay, or 4 for hexagonal, of course. That designate the crystallographic plans as determined from reciprocal of the fraction XL interceptions. Okay, you might don't understand what I'm talking about anyway. Let's do the practice and you will soon understand. So the determination of a Miller index of a set of number we call Miller index. There are 5 steps. Remember, 5 steps. Okay, the 5 rules for the procedures. Again, you can regard this as a 5 steps. So first one, it cannot pass, the plan cannot pass the origin. No, it's different from the direction. Direction, the step, there are 4 steps. The first step is the direction The vector need to pass the origin, but for the plane cannot pass the origin. Okay? Then what happens? You say that, Professor, what happens if the plane pass the origin? You just move the origin parallelly, or you just move the plane parallelly. Okay? Right, so the step 2 is the length of the plane intercepts. For example, this plane has intercept of the x-axis, y-axis. It might be an intercept with the z-axis or not. Anyway, you don't know, but you have A, B, C here. So this is called intercept. The step 3, after intercept, you have to do the reciprocals. What does it mean, reciprocal? 导数. Okay, 导数. In intercept, 截距, right? Okay, you have to do reciprocals. For example, A reciprocal, it becomes 1A eighth, right? This is 1B, 1C, right? You have to do reciprocal. So if a plane parallelly axis, if the plane is parallel to the x-axis, that means what? For example, this plane has no intercepts, so that means 0, right? That means 0. Or that means infinite, because it never touch. So we do the infinity. Okay, and the reciprocal of the infinity will be 0. So you use 0 to represent the axis in this case. Okay, these 3 numbers are changed to a set of the smallest integer. Again, the step 4 is after reciprocal 3 numbers. These 3 numbers need to become the smallest integer number. You can do multiplying or reduction. Normally it's reduction. Okay, and you use parentheses to enclose the 3 numbers, H, K, L. And this is what we call Miller index. This is parentheses H, K, L parentheses is called Miller index. Okay. Right, so let's start to get practice. 5 steps, right? You have 1, 2, 3, 4, 5, and I give you a plan here. So can you tell me these 3 numbers and enclosure by parentheses? Okay, first one, does it pass origin? No, it doesn't, right? So this is good. So this plan has intercepts in A, in x-axis, which is this length of in the x-axis is A, so it's half of A. And B here, in B, the length of B is in the y-axis. This intercept at B, so it's 1B. How about C? C, because this plane never touch the z-axis, which is we call infinite. So for this intercept is half of A, right? And B, and infinite C. Okay? Of course, you take this out. You take ABC out. So that's half A, half 1 and infinite. And after that, you do the reciprocal, right? Reciprocal of the 1 and half is what? Is 2, right? And reciprocal of 1 is 1. Reciprocal of infinite will be 0. So it's 2, 1, 0. And you need to do the reduction to make it become the smallest integer. So here is not necessary because this 210 is the smallest integer, right? So it's 210. And you do the enclosure, which is use the parenthesis symbol to make this. So parenthesis 210 parenthesis. So bingo. I know you are talking about a plan. You are not talking about a direction. Okay? Are you with me so far? Good, good. Right, so now I'll give you another example. Please work with me. So how about this one? This is in your textbook, example 3.8. How about this one? Can you tell me the Miller index for this plane? Okay, first one, does it pass origin? Yes. But the Miller index, the rule of the Miller index tells us the plane shouldn't pass the origin. So we have to move this origin, or we have to move this plane. So let's move this plane, or let's move this origin. O here become O prime here. You might say, well, Professor, can I move it down or upper or make it to the right? Yes, you can. That's what I'm going to tell you in the following slides. But just move to the right hand side, okay? From over the move the origin to the right hand side here, O prime here. So now let's say interception. The step 2 is intercept, right? So intercept in the x-axis is what? Infinite, right? So this is infinite. Y is what? -1. Z is what? Half of C. So that will be infinite -1, half of C, right? Of course, you need to take A, B, C out. So the parallel and -1 and half. And then after that, what is step 3? Reciprocal, right? Reciprocal. Okay, reciprocal infinite will be 0. Reciprocal -1 will be -1. Reciprocal half will be 2. Right? And then you might want to make this to make it to become smallest integer. 0, -1, 2, unnecessary, right? It's not necessary. So after that, you use parentheses to do the enclosure of these 3 numbers by parentheses symbols. So bingo. This is the Miller index address this plane. Okay? Okay? No problem. So this is what we learned. And then you might argue, Professor, I don't like you to move the origin from the left to the right. Okay? So this is from left to the right, right? Left to the right. This is what I just did this to you. Okay, you have O and O prime here. And you have X prime, Y prime, Z prime. So what we can get here is, just now I show you, this is 0, -1, and 2. Am I right? Yes. Then you might say, well, Professor, I don't like it. I want to move this origin to the left-hand side. Oh, so this is O double prime. Can we do this? Yes, we can. So once you remove the origin parallelly, you have to extend this plane, right? So if you extend this plane, and then this plane showing you, yes, you are talking about, if you talking about x-axis, y-axis, and z-axis, this plane will have intercept of this. This plane will have intercept of the x-axis, y-axis, and z-axis. So let's find out the Miller index for this plane. Okay, so for the x-axis, again, is infinite, right? For the y-axis, is what? Y-axis is +1. So this is negative, right? This is positive. For z-axis is what? It's -half of z, right? So for x, y, z will be infinite, +1 and -half of z, right? Okay, this is step 2. Step 3 is the reciprocal of this number. So reciprocal of this number is 0, 1, and -2. Okay, and step 4, smallest integer. Yes, this is smallest integer. It's 0, 1, -2. And after that, you use the parentheses to you enclose these 3 numbers by parentheses, right? Okay, this is the answer. And you might argue, say, well, Professor, this 0, -1, 2 is different from 0, 1 minus 2, right? But they are talking about the same plane. What's going on? Remember the family? They are the same family. Okay? They are the same. These two are the members in the same family. Okay? So you say, well, Professor, I don't believe you. Let's try another one. Okay, so if I move origin to the right hand side to the left hand side, can you move to the front? Yes, Professor, I don't like it. I want to move the origin to the front. That will be O triple pronged. Unfortunately, this plane also passes the origin, so it doesn't work. You say, well, Professor, I want to move this origin backward. Yeah, that's fine, but unfortunately, this plane passes the origin again, so it doesn't work. Okay, so you have moved from the left, move from the right, move from the front, move from the back. Can you move from the top? Yes, or the bottom. Let's move to the bottom. How do you say? Quadriprong. Anyway. Okay, let's move this origin down here. Of course, then we have X, Y, Z. And then we want to extend this plane, right? We want to extend this plane. Or however, because this one, if you have one more here, it doesn't touch X, Y, and Z, especially Z, right? So you need to extend one more. So use your imagination. In the end, it touches like this. So for the X, Y, Z, how about X? Again, X is infinite, right? X is infinite. Y is what? Minus 2. Z is what? 1. So that will be, for the X, Y, Z, that will be infinite, minus 2 and 1. So again, reciprocal, that will be 0, half of Y, and 1. And then make it become smaller as integer. 0, 1, 2. Right? Okay? 0, 1, 2. This number is very familiar. 0, 1, 2 here. Right? 0, 1, 2. So exactly we are talking about the same thing. Okay? So that's why I want to tell you there's a family for the direction. So there is a family for the plane too. Okay, so this is the one showing you that you can move this plane parallelly. Okay, so now let's start to practice. If I give you the number parenthesis 100 parenthesis plane, can you draw this plane for me in terms of the a cubic structure, a cubic? About 100. How can you do that? You have 5 steps, right? You have to move backward from step 5, step 4, step 3, step 1, step 2, step 1. So this is the one, and then you need to do what? Smaller integer. Yes, this is smaller integer, and you need to do the reciprocal. Reciprocal 100 is what? 1, infinite, and infinite. That means the step 2 is intercept, right? Intercept. You intercept 1 here. And the infinite intercept in the y-axis is infinite. So infinite is this one, right? And then infinite to the z-axis is this one. So as you know, this point here and infinite. So we are talking about this plane. Okay. No problem, right? Easy. So in your final exam, either I will give you this number, or either I will give you, no, in American they say either, okay, either, whatever. That's the British tone. Okay. Either I give you this plane and you give me this number, or I give you this number, you show me this plan in your final exam. Easy, right? Okay, let's work parenthesis 210 parenthesis. Can you do this for me? Small integers, right? Small integer. And then reciprocal, right? Reciprocal is a half of a and 1 and infinite, right? So half of a, or half of the x in the x-axis, and then 1 here and the infinite. So half 1 infinite. So we are talking about this plan. Okay. How about this one? 2 minus 1, 1 over bar, parenthesis 2 1 over bar, parenthesis. Again, reciprocal, right? Reciprocal is half of a, half of b, and minus 1. So half of a, half of b, and minus 1 in z. So you this one, half of a, right? Half. Of course, you can do the extension. Piece of cake, right? Easy. Right, so it's easy, so I just work, let's do this quick. So I give you the number and you give me the plan, I give you the plan, you give me the number. So infinite, 1, 1, so please work this for me, do it by yourself, okay? So how about this one? Let's do it. This is A, I give you a plan, again, I give you the plan, A, reciprocal, B, 1A, 1B, right? And then infinite C. So 1, 1, infinite. So that will be 1, 1, 1, parenthesis 1, 1, 0, parenthesis. How about this one? Half of A, infinite of B, infinite in y-axis, infinite in z-axis. That will be half A, infinite. Okay, reciprocals and 2, 0, 0. So 2, 0, 0 and parenthesis 2, 0, 0 parenthesis. So please practice this, okay? And then this might be the Kahoot next Friday. Okay, how about this one? That's again easy, right? So you know that's half. This is about 3/4, right? 3/4. 1 here, 3/4. Okay. So reciprocal that'll be 2, 1, 4/3. So if you reciprocal of this one, that will be 4/3, right? 3/4 reciprocal is 4/3. So, and this is challenge. It's not challenge. You need to make it become the smallest integer. So you have to times what? Times 3 for this, for all these 3 numbers. So that will be 6, 3, and 4. So you do the parenthesis 6, 3, 4 parenthesis. So this is the middle index address this plan. Okay? Easy, right? Easy. Right, how about family? So, you know, if I use caret bracket, that means the family of the vector of the directions. But if I use the brace bracket, this one, brace bracket, that means the family of the plan. So for example, when we talk about this one, 0, 0, parenthesis 0, 0, 1, 1, 0, 0, and 0, 1, 1, 0, 1, 0. This is the same, it's the members in the same family, right? How about this one? This is the same members. Now this is the members in the same family for the 1, 0, 1. If you use this brass bracket here and 1, 0, 1 brass bracket, this is the same. 101, 110, 011. This is the same family. Okay, so I hope you understand. So let's say that how many members in the family for the 100? How many members? 100 means what? 100 means this face. This is 1, right? Face. And then there are 6 faces in a cubic. So there are 6 members in the family. Okay? All the faces. So if you use curly bracket, 100 curly bracket, that will be, we are talking about these 6 represent the same things. Okay? How about 111? How many families? How many members in the family? Curly bracket 111 curly bracket. So if you talk about 111, that'll be here, right? That'll be this one. This is called 111. So how many members? Again, if you think of this, there are 4 members above XY axis. There are 4 members below XY axis, right? So there are 8 members. So the 111 and 1 over bar 1 okay, 1 over bar 1 1 over bar. Okay, so if you confused about this, you are more than welcome to come to me after the lecture, and we can discuss about this. Right, again, just now we are talking about a cube, because cube is that x length of A equal to length of B equal to length of C axis. But when we talk about tetragonal, that means length in the x-axis equal to length in the y-axis, but it doesn't equal to the length in the z-axis. So for the 111, as I just told you, that there are 8 members in the family, right? Okay, but for the 100, and then for the 100, 100 means what? How many? It doesn't mean this member, this member doesn't need to equal to this one. You know, this one, 100 is this one, right? 100 is this one. Equal to this one. Okay? But equal to this one. But 100 in this tetragonal plan doesn't equal to this one, but equal to this one. Right? So you need to be clear about the structure first. Is a cubic or tetragonal or whatever. And you start to know how many members in the family for a plan. Right, there's an interesting thing is that the direction, the plan is perpendicular to the direction. For example, this is this is a square bracket 0, 1, 0. And square bracket 0, 1, 0 will equal to the plan 0, 1, perpendicular to the parenthesis 0, 1, 0. So these numbers are the same, and they are always perpendicular to each other. 垂直的, okay? So this direction, right? This is the plan. They are 垂直, right? Okay. So the same as this one, this direction, right? This direction and this plan. How about hexagonal? Hexagonal is the same thing. I just let you notice. I think this one is A, B, and C, right? Let me see that. Right. So let me show you. Please work with me. Give me another 2 minutes. Let me finish this. Hexagonal crystal structure. This is for direction. This is for plan. And of course, you understand that the 4 indexes scheming for HKIL. Okay, so we already introduced you the direction. How about the plan? For example, this is the plan of the 1 over bar 0, 1, 0. Again, you follow the 5 steps. So 1 over bar means what? This is x direction, right? A1, right? So this is minus A1, which is here. And 0 is what? This is parallel to A2, so parallel here. And then Z is what? Sorry, A3 is this direction, so it's here. So you have 1 parallel and 1, you have dot here, and then a 1 here, and then parallel here, and a 1 here, and then parallel here. So you have this plan. Okay? And this is 0, 0, 0, 1. So 0, 0, 0, 1 means z-axis. 1 reciprocal is infinite, right? So infinite is this place. Okay? So please, so again, I just show you this so you can work out this by yourself. Right. So for the 4 index scheme, you can transfer these 3 numbers to become 4 numbers from the cubic structure to the hexagonal structure. Okay. So only I is different. So you use this I is equal to that h plus k. I equal to minus h plus k. Okay, again, you don't need to remember this. Once you need this, and you just find this, it'll be easy. Right, so this is a summary, and this is the Miller index. He's a great man. You know, he gives us numbers and to address a plan. So we have the same language to communicate to each other. Okay? Right, so that's it for today, and before you leave, let's call the roll.